Hello, Assalamualaikum. My name is Abdul Rahman and I am working as an assistant director in the Office of Director Road Asset Management System. So today I will talk about the Elmod 6 software, which is used for the payment structural evaluation for the data we have obtained from the phosphate falling reflectometer reflections. So, so this is the interface of the software. You see there is a project and certain icons, database, data file, and batch, and delete option and recent files. And then we have review data option, and then structure tab, and then moduli, then plot, and then parameters, then design and life cycle cost analysis, then options, settings, health, and exit. So let's explore these tabs first. First, whenever I'm going to create on a new project, I will click on the project, I will click on the database, and I will create the new database. But this tutorial is only limited to the interface of the working. So I'm going to open my database I have previously created. So I'm clicking on open, and here is my database. As you see, I will click on open and I will select this, and now the database is open. Then after opening a database or loading a database, you have to review the data. So here is the data review option. As you can see, these are the data review options. There are 70 number of data points and we have used 3 number of lots. Actually we have used 4. One is the sitting lot and it doesn't count in. So we have 3 lots of varying stress against 36, 45 and 56 kilonewtons, and these are the corresponding deflections against the applied loading. The change represent the distance, and we have the surface and air temperature with this. So if we know the asphalt temperature right here, previously it was unknown, you have to enter the asphalt temperature. You can click on asphalt temperature. If you have measured the asphalt temperature by thermometer, you can enter here and change the points here or enter here. But in our case we don't have asphalt temperature, so we rely on the bell curve. We click on the temperature graphs. As you see, this is the asphalt temperature after wear. It's used as we put the air temperature value here, mean temperature value of previous day temperature, and we H1 here represents the pavement overall thickness. Sorry, it represents the asphalt thickness. We put the asphalt thickness here and the load is applied there. So that's it. Then we click on save new data and okay. So next we will define the structure. In this case, structure is defined. We have the asphalt material at 84 mm thickness and base course is 560 mm and then infinite depth separate. You can also view the structure here. This is the structure and this represents the asphalt, this represents the base, and then we have separate. To get this we have used the, either way you can enter manually, but here we have used the GPR data. So GPR scans are there. We have 50 meter apart GPR scan and we have corresponding thicknesses for the asphalt and then 560 for the base. And for you can simply input the data, or you can import data file from here or simply paste Excel. So this is about this, and cancel. Next we have to define the parameters. For defining the parameters, you can use default or you can add new. For example, for this road I have defined for the Raipathoki road. You can create a new material, you can delete a material. I have defined a material asphalt concrete and it is bituminous. I have added the value at 2750 You can change the type here, and you can define the types, check mark the deformation types. I have checked it, and then you select the criteria. There are different criteria available. Since we are using the federal highway, so we are going to select this. And then we have temperature deficiency. By default, it is at 25 degrees centigrade. We're going to use this, and then seasonal. So these are for more accurate analysis, but we are doing it at surface level. Next, I will define my weight, vehicle weight. So my in Pakistan, it is designed at 88 kips, and it is 31 kilonewton. You see 80% of load is applied, and then the vehicle configuration, we have dual wheel single axle load, and you can define this seasons. We have defined only one season, and at 100% you can define a number of seasons. Here you have 12 seasons, and you can define the number of weeks in each season and the percentage of loading in each season. So similarly for the base, it is an unbound material. You have base some other type, bituminous base or semi stabilized also, and corresponding you have to put the values here and check for any cracking or deformation if you have any. And vehicle and wheels path will remain the same. And next we have subgrade. You define the subgrade. Subgrade we have using James Kirk unbound criteria, and that is also unbound, but there is a permanent deformation. You have to check mark it for the permanent, and you also define the design life here, and we have defined the spot life of design here, and base design life plays an important role during the analysis. So you can either create a new setup, save as new setup, save as new permanent, or simply save the setup. Since it is already analyzed file, so I'm going to close it. No, I don't want to modify my data set. Right. So next come the plots and the moduli. Since we for calculate this, we click on the overlay design criteria. You see here it is, and we have approved asphalt cement. First, we have also milled the layer up to 50 centimeter. I can choose which drop I want to add for. I have chosen here the drop 3, which is the maximum, and this is the total passages per year of the vehicle. You convert it from SLs, and you click on start design. So you have to choose the section first. Okay, you click on start design. The design is completed. You can click on view plot. Here you see the plot design overview, and it shows a remaining life about 26. You see, and life analysis there. You required a very zero and overlay of at least very high values of overlay are required to sustain it for 10 years. You simply click it. You have other plot. Click on plot. You have deflections data here, surface moduli data here, and then voids data there, and then thickness data is also, or E moduli values there. Deflection comparisons are there, and you have life and overlay values here. Seasonal moduli values are there. Accumulated damage values, payment response. So you have a number of tools here. You can search out that, and you can also section the. For example, I want up to 5 kilometer. I will click in start and then drag here. It will show add up to this sectioning. And our topic is simply you can create a new design here. You define the material type here, what you want to asphalt base, and then thickness, and then you put the vehicle types, and you will click on start design. But for this tutorial, we are going to focus on the overlay analysis, and this tutorial only gives you the overview of the Elmod 6 and the functioning which you can use to interpret your results. For detailed analysis, we are going to have another series. So stay tuned and thanks for listening. That's it from my side, and thank you very much.